Stay at home. Okay, good word. Stay at home. Don't go out. Right now, viruses are everywhere. Okay, let me share my screen. Okay, what I'm going to do is this question today, the B. Last time I changed it to the EC minus 2KD. Then I want you to do these two questions. Have we done these two questions? A and B. I think B we still haven't do. A, have we done this? A. Anyone still remember this? Hello? Boleh dengar tak? Okay, never mind. So we do these two questions first, then we only proceed to the discussion. So the notes is already uploaded into the Google Classroom. You can go to there and refer it. So after doing all the questions, you just click a yes. You don't have to choose no now. I just want to know how many of you have done the question. I have already launched a poll. You can select. After done, then only click yes. Haven't done, don't need to do anything. lao log jing is 1 EV to 2 EV. Okay, not 1 to 2 EV, 1 EV to 2 EV. Okay, remember, for those who have completed every question, try to click yes in the poll. Okay, shall we continue to discuss this? Anyone? Is it okay? Okay, so let's see. So the first question is kind of simple. Okay, so can anyone tell me the answer for the first question? Okay, let me see. Ong Mei Ling, are you here? So what's the answer for the first question? A and B. You give me the answer of A. Okay, 1.2827 times 10 to the power negative 28. Okay, correct. Okay, let me select the other guy. BOEC. What is the answer for the 1B? Okay, BOEC, are you here? Okay. I get a different answer compared to the DOEC one. Okay, anyone get a different answer? My answer is 8.29 times 10 to the power negative 10 to the power 27. Chu Zhang Heng, what about you? What's your answer? Okay, my answer is the same like Li Zhelim. Chu Zhang Heng, your answer seems weird. Any other people getting the same answer as me and Li Zhelim? Okay, so I believe my one is the correct one because I just copy and paste the thing on it. Okay, the one tricky a bit is question 2B. Determine the number of the quantum state in the silicon between the EV minus KT and EV. Okay, you can see right now it's a EV minus KT and EV. So this one is a little bit tricky. So let's see how we're going to do with this question. So the very first formula, we can know that this one is using the valence band. When we are dealing with the valence band, we are going to play around with this thing. Okay, this question, this formula. Okay, so let me copy and paste here. Okay, so the original formula is like this. G V equals to 4 pi 2 mp asterisk 3 over 2 Q EV minus E. Okay, you can see that here is using MP. So according to the table below, for the silicon, we are using the first column. Okay, but we are getting the MP. See this. MP divided by MO will be equals to 0.56. So your MP, extra MP, will be equals to 0.56 multiplied by MO. So eventually this MP will be equals to 0.56 multiplied by MO. Okay? So the only tricky thing is here. And we may proceed to our further integration. Okay, let's see this. So we know that GC equals to this, we need to do the integration of GC. And then based on the question given there, we get some information here. EV minus KT and EV. Okay, so EV minus KT, then GE, DE. This thing will be further copy this thing. Okay, DE. Then we do the further integration. We change it into the A for us to be easily to write. Then 203. Then EV minus E 302. Okay, then we further doing this. Okay, so this thing. Okay, let me rewrite. So this thing should be under EV minus KT. Okay, then we can put the value inside there. Okay, then this was a EV minus EV 302 minus A 203 EV minus EV plus KT 302. So this one we can remove because this one will be equal to 0. We need to focus here on here only. Okay, you may see a negative sign, but don't worry. Later we just take the attitude value, magnitude value, that is more than enough. So we just use this value, then we put back, then we should get the answer. Okay, what do you get for the answer? Anyone? Let's see. Kwai Yihang, are you here, Kwai Yihang? Kwai Yihang? Okay, let's wait for Mr. Kwa for a while. Okay, or maybe Chua Yu Yang, are you here, Chua Yu Yang? So for my answer, I will get 7.9 times 10 to the power of 24. Okay, Kwai Yihang gets 6.2. What about the rest of you? The most important thing one is using the 0.56 in this case, because the efficiency is a 0.56. So that's why you need to use 0.56 instead of using a 1.08. Yep, 7.9 times 10 to the power of, I'm not sure it's 24 or not, but I'm not sure it's 18 or not, but I get 24. Okay, for the rest of you, do you get the same answer as me? But we just take the magnitude value, ignore the negative value. Lô Thiong Lê, are you here? What is your answer for this question? Okay, so this is basically the way that we do the question. We will get the magnitude value. Okay, so I think Lô Thiong Lê gets the same answer as me, which is the 10 to the power 24. Okay, so this is the way we do it. Any question? If not, then I proceed to the rest of the lecture. No worry, today will be very fast to end the thing. right now 3:30 already. Okay, so after studying all these density, we call it as a density value. Okay, then we also need to understand the Fermi direct distribution. What is the Fermi direct distribution? So basically, Fermi direct distribution is, let's say, if given this one is a EC, EV. Fermi direct distribution means the probability of an electron exists in here or not exists in here. Okay, which means that the Fermi direct distribution is the probability to know the chance whether we can find the electron in the energy state that obey the Pauli exclusion principle. What is the Pauli exclusion principle again? Which means that two electrons will not be having the same energy quantum state. This is what we have learned in the first lecture in this week. Okay, so we need to know how to calculate the probability. We also need to know what is the Fermi energy level. What is the Fermi energy level? Fermi energy level means that what is the maximum energy level the electron can have under the 0K. Okay, you can see this. This one is the maximum kinetic energy an electron can reach in the 0K. Okay, maybe the 0K, the Fermi energy level is somewhere around here only. Maybe EF. Or maybe somewhere around here. EF. Or maybe somewhere around here. EF. We don't know. It depends on the silicon or depends on the semiconductor. So there are two terms. Fermi direct distribution, which is the probability, and the Fermi energy level. So in this lecture, we will be looking at the probability on how to calculate the probability. So the probability can be calculated using one formula. Okay. So the Fermi direct distribution or probability distribution, you call it as a P, or in this slide using a FE, is calculated using this way. 1 plus exponential energy level minus Fermi energy level over KT. Okay, this formula is the probability that electron can be found in conduction band. Okay, last time we tend to know that, okay, this one is a EC, EV, valence band, conduction band. So most of the electrons staying around here, but once you are providing the energy, it will jump from here to here. Okay, this probability is to saying that, okay, maybe in somewhere in the energy level here, E. Okay, what are the probability of finding the electron staying in this energy level if you provide the energy to jump here from here? How to calculate the probability? Okay, so this is the formula. So that's why I can say E. This E is the same as this E. Okay, then maybe the Fermi energy level is somewhere around here. Originally, we know that all the electrons are here, but what are the probability of finding it in here? Okay, or the other formula is 1 minus 1 plus exponential E minus EF over KT. Okay, this formula is the other way around. This is the formula that probability that the electron not in the valence band. Okay, which means that somehow it provides you energy. So what are the probability that, let's say in this E, the electron is not existing here? This one is cosine. This one already jump over there. So in order for you to do this, you just use 1 minus this, then it's okay already. You may be quite confusing, but never mind. Let's try to do some simple question so that we can know. Okay, for example, this question. Find a probability that the energy level 3 kT between the EF is occupied by an electron at a 300 K, which means that EC, EV, maybe EF somewhere around here, EF somewhere around here. So this is a EF plus 3 kT. So find the probability that the electron exists in the conduction band and is located here. So to do this question, you just need to apply the formula. F equals to 1 over 1 plus exponential E minus EF divided by KT. Okay, you further replacing the value. 1 plus ESP EF plus 3 KT minus EF over KT. Okay, so things are getting easy. This one delete, KT remove. So 1 plus exponential 3. So eventually the value you will get 0.0474 equals to 4.74%. By using this formula, we can know that there are 4.74% of the probability that the electron will be somewhere around here. Okay, this is how we do it. Very simple only. Okay, so this is another question. Okay, let's see. It's the other way around. Assuming the Fermi energy level for a particular material is 6.25. Okay, and this one is follow the Fermi direct distribution. Calculate the temperature at which there is a 1% probability that the state 0.30 below the Fermi energy level will not contain an electron. Okay, right now, you see something like this. Okay, this is EC, EV, EF, he gives you is a 6.25. Okay, then maybe it's 0.3, 0.3 and below. In this energy level, somewhere in the valence band, the electron will not occupy somewhere around here. And the percentage is 1%, 0.01. So let's see this. So as I mentioned just now, in order for us to do this, we need to use 1 minus 1 plus exponential E minus EF over KT. Okay, so right now, we know that the Fermi energy level is 6.25. Then E is 0.30. Okay, this thing 6.25 minus 0.30 is 5.95. And he asks us to find the temperature. Temperature is this T. 1 plus exponential 5.95 minus 6.25 over KT. K is the Boltzmann constant. Then you need to find a T. But both of these things are actually using the EV. Okay. So in order for to do this, we need to use the KT in the EV value also. Okay, in order for to do this, maybe you can get back something like this. And then open this. Lecture 2. Okay. You can see that KT original is 0.0259. Okay. 0.0259 is under the 300 T. So for you to do this, your K must be using the EV also, which means your K is using a 8.62 times 10 to the negative 5. Okay, based on all this value, you can calculate the T. Okay, so in the lecture slide already given you the answer, which is 7.56K, 756K. Okay, so let's try example. So for example, question 1. Assume that the EF is 0.30 below the EC. Okay. Determine the temperature in which the probability of an electron occupying energy state at E equals to EC plus 0.025 is x times 10 to the plus negative 10, negative 6, sorry. So the formula is like this: E minus EF over KT. So we know that EF is EC minus 0.3. Then your E is EC plus 0.025. So all you have to do is to replace the value here, replace the value here. So 8 times 10 to the negative 6 equals to 1 plus exponential EC plus 0.025 minus EC plus 0.3 over KT. Okay, then your K is 8.62 times 10 to the power negative 5. Okay, everyone, calculate me the T. So this one can be deleted, so this one can be added together. Okay, try this. Then tell me the answer, everyone. After done, then you type your answer box. Okay, what's the answer for this question? Anyone knows? Okay, so Yen Chang gave her the answer 221. The rest of you, are you getting the same answer? Okay. So I guess the temperature is about 321 or 322, more or less around like that. So always remember in the microelectronic, you need to deal with all the formula. Okay, let's try the last question. Then we can dismiss the class by today. So let's see how we play around with all these questions. Okay, so this EF if EC minus 0.3, when T is 300, then your E will be equal to EC plus KT over 4. Also find the probability. 1 plus exponential E minus EF over KT. KT. Okay, one hint for you. If T is 300, then your KT must be always equal to 0.0259 EV. Okay, because your K is 8.62 times 10 to the power negative 5. So when you're using this multiplied by 300, you can always get 0.0259. Okay, so in our microelectronic, we always use 0.0259 as long as T is 300. But sometimes you will cannot trap also, you need to be extra careful when dealing with this. So in this case, let's replace all the value inside here. 1 plus exponential. Okay, EC minus 0.3. EC plus E equal to EC plus KT over 4. E plus 0.25 KT minus EC minus EC plus 0.3. Okay, then divided by 0.0259. Delete 1 plus exponential 0.25 KT plus 0.3 over 0.0259. By calculating this, you are able to get the probability. Okay? Then if you are done, you type the answer in there so that I can have a look. Okay, by the way, today COVID cases is about 90,000 already. So everyone please take care and don't go out if nothing to do. Stay at home. Yeah, really high. 9,000 cases, crazy. Okay, everyone, once you get the answer, you just type your answer into the chat box. Okay, so Yan Chang get the answer of 7 by 1 3 times 10 to the power -6. What about the rest? Do you get the same answer as well? Wong Chun, you get a different answer. So let's see the rest. Why all the answers are very, very one? Okay, what about the rest? Joe Yixi, Lim Yong Chuan. Okay, seems that Yao Ting answer is more valid. Okay, let me calculate on my side. Okay, 7.26. 1 divided by 1 plus exponential 0.25 multiplied 0.0259 plus 0.3 divided by 0.0259. How come my answer so different one? Have I done anything wrong? Okay, let's check. Okay, exponential, no wonder. Okay, let me check the answer again. Okay, 0.26 times 10 to the power -6. Okay, so I believe this one is the more accurate answer. So some of you may have some round error, it's okay, no problem. So I think that's all for today. Thank you very much for your attention. Any question? If no question, then I may stop the class now and everyone have a good weekend. So by the way, our I plan to have our test by about week 5 or week 6. Is that okay? Week 6 or week 7 like that. Is everyone okay with this? Okay, if no question, then I think I will stop for the day. Thank you very much for the attention and have a good weekend.